For centuries, we've kind of put mathematics on this pedestal, right? Like it's some grand, mystical temple of logic, a place where only a select few geniuses hold the key. But what if that's not the whole story? What if the key isn't some secret knowledge, but actually a different way of thinking? Well, let's dive in and find out. Listen to the ancient Greek philosopher Proclus. He perfectly captured this really intimidating view of math. He said it awakens the mind and purifies the intellect. It sounds beautiful, it sounds profound, and let's be real, kind of terrifying. It feels less like a school subject and more like some kind of spiritual quest. But then, bam, in walks one of the greatest living mathematicians, Terence, and he just cuts right through all that ancient mystique. His take? He just likes mathematics because, well, it's fun. Fun? Seriously? How can something that feels so complex, so unsolvable, actually be fun? That's exactly what we're going to get into. So, our guide for this whole adventure is Tao's own book, Solving Mathematical Problems. It's basically a look inside his brain, a peek into the strategies and the mindset that can turn these daunting challenges into, you guessed it, delightful puzzles. We're going to unpack his core ideas right here. Here's the game plan. First, we'll look at why you should think of math as a game. Then, we'll talk about the goal of that game, which is finding an elegant solution. After that, we'll get our hands on a practical strategist's toolkit and see how it works on a real problem. And finally, we'll talk about the journey of what it means to become a better problem solver. All right, so first things first, let's get into Tao's main idea here. I want you to completely forget about math as a grind, as some kind of mental brute force. Instead, think of it as a creative and strategic game. It's not about how hard you can dig, it's all about knowing where to dig. Tao has this amazing analogy for it. He calls it the gold prospecting analogy. So picture this. A good math problem is like a gold nugget, hidden somewhere really clever. Now, you know for a fact it's there, and you've been given all the tools you need to find it. The challenge isn't to just dig up the entire landscape, that's brute force. The real challenge is to cleverly figure out its hiding spot. See how that reframes it? It goes from being a chore to a playful, clever hunt. Okay, so if it's a game, what's the goal? Is it just about finding the gold nugget? Not quite. For a true mathematician, just finding it isn't enough. They want to find it with style, with grace. They're on the hunt for the most beautiful, the most insightful path to the solution. And Tao draws this incredibly powerful contrast. On the one hand, you've got the clumsy solution. He calls this strip mining the neighborhood with bulldozers. You take a nice, simple question and turn it into what he calls a ravening monster of an equation. But an elegant solution, that's like doing a careful survey, a little geology, and just a small amount of digging. It's short, it makes sense, and man, it gives you this amazing feeling of victory. All right, let's make this real. Here's a classic geometry problem. Prove that the three perpendicular bisectors of a triangle's sides all meet at a single point. Now, you could attack this with coordinate geometry, setting up pages of messy algebra. That's the bulldozer. Or we could try the elegant approach. So check this out. Let's just pick a point, P, and say it's where two of the bisectors cross. Okay, now by the very definition of a perpendicular bisector, any point on it is the same distance from both ends of the line. So the distance from P to A has to equal the distance from P to B. Simple enough. And since it's on the other bisector too, the distance from P to A also has to equal the distance to C. Wait a second. If P to A equals P to B, and P to A also equals P to C, well then P to B must equal P to C. And that simple fact means that point P absolutely has to be on the third bisector too. Boom, they all meet at P. No monsters, just pure, simple logic. Okay, that is beautiful. But how do we come up with that kind of insight ourselves? How do we find these elegant paths? Well, it's not magic, it's all about strategy. And luckily for us, Tao lays out a practical toolkit for our own gold hunt. And it really does start with the basics. First, you have to understand the kind of problem you're facing. Are you trying to show that something is true or find a specific value? That sets your direction. Then you understand your data. What have you been given? What tools in your arsenal, like theorems, might apply? Next, and this one is absolutely crucial, you have to select good notation. The right choice here can make a problem's hidden structure just pop right out. Then get it all down on paper so you can see the connections. And finally, you use those tools to simplify, 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 and solve. Okay, so theory is one thing, but let's actually see how this works in practice. We're going to grab a problem straight from Tao's book and walk through it step by step using this very toolkit. So here's our new challenge. We've got a triangle. We know its area, which we'll call T. We also know its three side lengths are in an arithmetic progression, like 3, 5, 7, with a common difference of D. Our job is to figure out the actual lengths of those three sides.
First step, notation. We could just call the sides A plus D, and A plus 2D. That totally works, but it feels a bit lopsided. A much smarter, more elegant choice is to center the whole thing around a new variable, B. So now our sides are B minus D, B, and B plus D. This isn't just about looking pretty. This symmetry is a powerful strategic move. By centering the terms like this, we've introduced a positive D and a negative D that are just begging to cancel each other out later. It's going to make our algebra way, way cleaner.
Okay, step 2. What's our best tool for the job? We think about our options. The sine rule? The cosine rule? Maybe. But they bring along friends we didn't invite, like angles, which we don't know. But then we remember Heron's formula. It's perfect! It calculates the area of a triangle using only the lengths of its three sides. It's the most direct bridge between everything we know, the sides and the area, without adding any new complications. And this is where it all comes together. This is the payoff. When we plug our supersymmetrical notation, B minus D, B, and B plus D, into Heron's formula, the algebra just melts away. It simplifies beautifully, exactly like we planned. Those D terms cancel out in all the right places, and what could have been a total monster of an equation collapses into this, a single, clean, solvable equation. See? The right strategy and the right notation didn't just find an answer, they carved out the elegant path that was hiding there all along. And this really gets to the heart of it, This whole problem-solving thing, it's a skill you build over a lifetime. Tao really emphasizes that your perspective on math just keeps evolving. It's a journey, not some fixed destination. He lays out this really cool progression. In high school, math feels like a sport, right? You're just trying to find the clever little trick to unlock the puzzle. Then, as an undergrad, you're suddenly in awe of these deep, beautiful theories and structures. But as a professional, a whole new level of understanding kicks in. You start to see how even the most ridiculously complex results are almost always guided by simple, common-sense ideas.
And that, right there, is the real prize. It's what Tao calls the aha experience, that moment you finally grasp one of those simple guiding principles, and suddenly a whole area of math that seemed impossible just lights up. It's a feeling of deep understanding that is so much more satisfying than just getting the right answer. So if you take away just one thing from all this, let it be this. The ability to solve hard problems is not some magic gift you're born with. It's a creative skill. It's a strategic mindset. And just like any other skill, it's something you can learn, you can practice, and you can get better at. It's not about being a math person. It's about learning to think like a gold prospector.
So let me leave you with this question. And it's not really about math at all. Think about your work, your hobbies, your life. What's that one problem you've written off as just unsolvable? And what might happen if you stopped trying to attack it with a bulldozer and instead started looking for that clever, elegant path?